So let's start the session. For the second session today, we have Omkar Sabre as our speaker. Omkar is a passionate teacher and has been teaching mathematics and statistics for CA, CWA, and CS students. He also teaches at Bhas Bhamar Academy and has been a volunteer for many camps at Ram Foundation like Ram TP and Epsilon as a teaching assistant. He has presented a research paper in AIMER conference in 2019. He also runs a YouTube channel named Maths is Life. Maybe some of you must be interested in joining his YouTube channel. Do subscribe. He is an investment advisor by profession and a FIDE-rated chess player. Presenting mathematical chess problems and mathematical magic tricks are few of his hobbies. He knows Sanskrit very well, and that helps him to correct mathematics with a beauty in the Sanskrit language. So I'm sure you all must be waiting eagerly to hear from him. So over to you, Omkar.
Thank you so much. For today's part, I will take the probability and the especially expected value from the probability. That part I will cover today. So I hope everyone is at least familiar with the word probability. What do we mean by probability? If anyone wants to tell what he knows about probability, they can just raise hand. Yes, aim.
Yes, sir. According to me, probability is the chance of something to happen.
Okay. Chance of something to happen. So, meaning wise, it is correct. So, in life, there are many incidences. Like the first one, oh, I am just turning off my video because of network. Okay. So, there are two types of events. Suppose if you press the button on your remote, suppose this is your remote. If you press this button on your remote, obviously the remote of TV. Okay, so what will happen? Either the TV will become on or off. If it is on already, it will become off. If it is off, it will become on. So by looking towards TV and by pressing the button, we can confirm know the result that whether the TV will become on or off. Right? Suppose there is pizza and you have taken a bite of pizza, then its result also we know it will go in stomach, and before that we will know its taste. So here when the results are confirmed, that types of events are known as deterministic events. Deterministic events. But when there is not only one possible outcome, here the outcomes are fixed, right? And only one possible outcome is there. If the TV is on, then it will surely become off. If it is already off, it will become on. Right? So such results where such events where results are fixed, it is deterministic. And the second part is probabilistic. Probabilistic events. What are such events which are probabilistic? Suppose you are going to school. Here is your school. Okay, here is your school. Here is your home. You're leaving the home so that you can reach the school. Here is your path, let's say like this. This is your path, and here are two signals. Here are two signals. So probabilistic events means it is sure that when you leave the home to reach the school, you will reach the school. It is perfect. But the question is, are you sure before leaving home only? Are you sure that how many red signals you will get? It is possible that you will get none of the red signal. It is also possible that you will get only one red signal. It is possible that you will get both red signals, right? Or suppose you are watching YouTube. You are watching YouTube videos. I forgot the YouTube symbol. So let's write YouTube. You are watching YouTube videos, and suppose you have watched 10 videos. So before watching these 10 videos, can you tell that, oh, I am going to watch 10 videos. So out of that 10 videos, I am going to like these many videos. It is possible that you will like none of the video or one video or two video or any number of videos. Here everywhere we know all possible outcomes. Here we for this condition we were knowing that either we will get zero red signals or one red signal or two red signals. Here also we know either we will like zero videos or we will like one video or two video or three video till 10 videos. Okay, that ranking can be different, but at least we know these values, possible outcomes. We know all possible outcomes. Now, always probability will not be same. Probability means what? How occasionally that event happens. Suppose you are going from home to school every day, and every day you are getting both red signals. Then, according to you, the probability will be 100%. That 100% I will get both red signals. It is not actually 100% probability. Just you are getting such results. Probability will be 33%. Why? There are three outcomes. There are three outcomes. So always probability is 100% as a total, and there are three such outcomes which are evenly possible to happen. That is, there is no biasness. What is biasness? That also we will see. So, like suppose there is a coin. On the back side there is tails. On the front side there is heads. So we know that heads can comes 50% times and tail can come 50% times. So when we say it can come, it is not necessary that it will come. For example, if I flip the coin 10 times, okay, or I flip 10 coins, then according to probabilities that 50% chance is happening heads and 50% for tails. So 50% of 10 is 5. That is 5 times we will get heads and 5 times we will get tails. This is according to probability. But what happens when I do it practically? I flip 10 coins and I get 0 heads and 10 tails. Does it mean that probability is incorrect?
No,
Or
sir.
I flip the incorrect coins? What it means? So probability is not incorrect. Probability is just guess. It is just guess that what can happen. It is not 100% sure that it will happen. No, it is just telling you that if you do it continuously, then this result can come averagely. Okay, not every time, averagely. Take the same event that 10 coins you are flipping. 10 coins you are flipping. Sometimes you are getting 5 heads and 5 tails. Sometimes you are getting 4 heads, 6 tails. Sometimes you are getting, let's say, 7 heads and 3 tails, or 10 heads and 0 tails, or 2 heads and 8 tails. All possible outcomes are there, right? Any number of heads we can get, any number of tails we can get. But if you do it continuously many times, then its average will be this probability. Not exactly, but somewhere near to this probability. For example, because of these different numbers, probability can come like you will get 4.9 heads and 5.1 tails. But practically it is not possible to get 5.1 tail, right? Or 4.9 head. So we just make approximate to do that. Okay. So this is probability. So there is one more concept in that, that is probability distribution. Probability distribution table. Distribution. What happened to this page? Okay. So generally we take variable as x. That x variable represents the event. That event we decide in the beginning only. Okay. So suppose we are flipping the coin, just one coin. Just we are flipping one coin. So we know either we can get heads or tails. So x, here we will not write in front of it heads and tails. The event will be of getting either one head or getting zero heads. Okay. So the event will be for one variable only. We will not include tails here. Either we can take tails or heads, not both. So we can just write that X is event of getting heads. Okay, or in other words also we can write X is number of heads. X is number of heads. Anything you can take. Okay. So either we can get zero heads or we can get one head. Now what is probability of getting zero heads? Okay, getting zero heads means what? We are getting tails. And getting one head means what? We are getting heads. So both are 50%. Right? So in the first column we write the outcomes, and in first row we write outcomes, and in second row we write its probabilities. So how much chance is there for getting zero heads? It is just 1 by 2. That is, there are two possible outcomes. One outcome is for zero heads and one outcome is for one head. Suppose we are flipping two coins. Then first outcome we can get heads. Second outcome can also be heads. Or first outcome can be heads, second can be tails. First can be tails, second can be heads. First is tails, second is tails. So when we flip two coins, there are four outcomes, right? So for two coins, let's make another probability distribution. Here X is again number of heads. So either we can get zero heads, right? Zero heads. Or we can get one number of heads. Or we can get two number of heads. So these are the only possible outcomes. There are four possible outcomes. So denominator will be the total number of outcomes, that is 4. And in numerator we will let the required outcome. That is, first is zero heads. So how many zero heads are there? 1. How many one head outcomes are there? There are two such outcomes, either heads tails or tails heads. So we will write here 2 by 4. Then for two heads, there is again one outcome. So it is again 1 by 4. And this is just P. We will write here P. That is, P represents probability of that event. Okay. In some textbooks, possibly you will find this P like this. Instead of just P, they write P of capital X equals to small x. There is another reason for writing this that we will not discuss right now. But this is also the way, and both are same. No need to worry if you see that. Okay, now this is probability distribution. Today we will be working on this only, probability distribution only. Okay, so first of all, what will be probability of getting 3 heads by flipping 5 coins? I'm just giving 1 minute. You can get answer of this. If you want, you can make probability distribution table for 5 coins, or if you want, you can just write down all possible outcomes.
Sir, 3 by 10?
3 by 10, no. You can just put your answer in chat box so that others can also solve and answer will not get leaked.
Sir, is it 3 by 8?
3 by 8, no. See, first of all, we need to understand how to count total number of possibilities when there are 5 coins.
Sir, is it 1 by 10?
1 by 10, no. See, when there is only one coin, then which are the possible outcomes? Either we can get heads or tails. So there are two outcomes for one coin. When there are 2 coins, outcomes will be either heads tails, or tails heads or tails tails. So there are 4 outcomes here. When there are 3 coins, then outcomes will be like this: heads or heads tails, or heads tails heads, or tails heads, or tails tails, or tails heads, or tails heads tails, or heads tails tails. So there are 8 outcomes. So by observation, we can say that these are just powers of 2. This can be written as 2 raised to 1. This is 2 raised to 2. This is 2 raised to 3. So obviously for 5 coins, what will be total number of outcomes? That is 2 raised to 5. And it will be 32. So there are 32 possible outcomes when you flip 5 coins. So the denominator of this will be 32. Now we need to think about numerator. Now when there are 5 coins, so there are 5 places, right? 5 possible outcomes in that one only. Okay. And we need to select such outcomes where there are 3 heads. So let's try to get that heads, 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 tails, tails. This is possible. Or heads, heads, tails, heads, tails. This is possible. Or heads, heads, tails, tails, heads. This is also possible. And there are many such outcomes. I am not just going to write down all of these. Okay. I'm just telling that there are such 10 possible outcomes. If you do it on your own, there are 10 such possible outcomes. So the numerator will be 10. There is one trick for this. For doing this, there is trick that I am not going to tell you. It is just a part of combinatorics which you will face afterwards. So 10 upon 32 can be written as 5 by 16. So this will be the answer. You can just count by writing down all possible outcomes. You will get the result. So just moving forward fast so that we can move towards expected value. Now, what do we mean by expected value? Is there anyone from you who have heard expected value or till now? Or knows what it is? Sai Charan.
Yeah, I have heard about expected values. Expected values basically, you can say average of the possible outcomes.
Average of possible outcomes, right? Right. So it is average of possible outcomes is not its meaning, it is its method of calculating
But yeah,
expected
but
value.
we need to multiply the outcomes with
Yes,
the
yes,
probability.
yes, correct. That is the method, but meaning of expected value is just simply we can say what we expect to happen. For example, I am taking again a simple example. Suppose there is dice which have 6 sides and numbers 1, 2, 3, 4, 5, 6 from the 6 sides. Obviously normal dice, not biased dice. So what will be probability distribution of that? Probability distribution will be like this. Either we can get 1 or we can get 2 or we can get 3 or we can get 4 or we can get 5 or we can get 6. See, there are 6 possible outcomes and each outcome is equally likely to come. So its probability will be 1 by 6 for okay, and back. Just network issue was there. So probability for each outcome will be 1/6. Now, when you are throwing the dice, what result do you expect? Do you expect to come 1 or 2 or 3? See, I'm using the word expect. I'm not using the word what you want. While playing, you want 6 many times, but what do we expect to come? That can be different. So to get the expected value, we just do the simple thing that we just multiply values of x and p together. Okay, the outcomes and its probability. We just multiply. So here it will be 1 by 6, here it will be 2 by 6, here 3 by 6, then 4 by 6, then 5 by 6, and then 6 by 6. Once we get all these values of this product, we just add all these values. Okay, so its addition will give you 21 by 6. Okay, and it will be somewhere perfectly 3.5. So when you throw the dice, see, expected value written as like this, expected value of x. Okay, so the result is here 3.5. What it means that when you throw the dice, on the face of dice, you will get the number 3.5. So these expected values can be such illogical also. Like here, we know when we throw the dice, only these 6 values can come. 3.5 cannot come on the dice. Okay, so what he said right now, that expected value is just like the average. Instead of frequency here, we just have probability. Otherwise, the method is same.
Sure, but why don't you just find the average of x? Why do you multiply it?
Why we multiply it? Because here probabilities are same. Suppose if there is unbiased dice, where let's say the dice is like this. So let's say like this, where the probability of coming 3 and 6 is very rare. 3 and 6 comes rarely, where 1 and 2 comes most of the times.
Okay.
So in that case, probabilities will change. So we need to take the product of these results. That is, what is the value of each outcome and how likely that outcome can come.
Okay, yeah. And so what have you written in the third column, third row?
Third row is just product of these numbers x and p, xp.
Okay.
That is x. Okay, so this is a method of getting expected value. Here I am not expecting that you will be very perfect in 1 hour just to get expected values. Just I am giving you rough idea of what it is actually and how we can use it in real life. So here I have taken one example. This is just for practice. So there are just numbers. Let's solve this first to get expected value. Okay, here is the question. You can just solve it and comment the answer.
Omkar, we are not able to hear you properly. Are you saying something?
Oh, okay. Am I audible now?
Audible, but still, I mean, not so clear actually.
Okay. Okay, is it clear now?
Yes, it is better. Thank you.
Okay, okay.
Sir,
Yes.
sir, what is F?
What?
So what is F in this?
Oh, sorry, not F. Here I have to write P. That is probability of that outcome.
Okay, sir. Okay.
And sir, x is the value, right?
Yes, X is value.
And what is px again?
Oh, this E of X.
Yeah, what is e of x?
It is expected value. That's what we have to find.
Okay, and what is px, xp?
XP is just product of these two numbers. Oh, wait. Oh, here I have given integers.
Sir, how do we answer?
Yes, yes, wait. Here, the
Sir, I
one,
think the P table should be fractions, right, sir?
no, one mistake is from my side. I'm just erasing these numbers. How the probability can be more than one? Hmm. Here, let's say point 0.1, here point 0.3, here point 0.2, here point 0.3 and point 0.1. Now we can solve. Sorry for wasting time. See, here one more thing from that mistake, I should explain that probability cannot be more than 1. Yes, you can write it as 10%, but remember 10% is again 0.1. Probability cannot be more than 100%, and 100% is what? 1. So here you cannot get any value more than 1, or even it cannot be less than 0. So probability always be more than 1, but oh, I have given opposite symbols. It should be like this. Probability is more than 0 and less than 1. Okay. Okay, answers are coming. So let's see. 10 into 0.1 is just 1. Then 30 into 0.3 is 9. 50 into 0.2 is 2.5. No, sorry. It is 1. And then again plus 70 into 0.3 is what it is. What is 70 into 0.3? It is 21. And then 90 into 0.1 is 9. So just add all these values. We will get here 41.
Sir, isn't
But-
50 to 10?
Yes, sir.
Oh,
Sir,
right.
50 into
Right,
0.2 is 10, sir.
It is 10, 10. So it will be 50. So we expect to get the result as 50. Again, you know why here the mean have come. Oh, mean of x, if you take instead of expected value, if you take just mean of x instead of probabilities, just consider the values, you will again get the same answer as 50. And the reason for this is the difference between the values of x is same, and also the probabilities, you can see they are symmetric. That is, first one is 0.1, last is also 0.1, second is 0.3, second last is also 0.3, and this middle is 0.2. So
Sir?
it is symmetric. Symmetric means on both sides they are same.
Sir,
Yes.
sir, can we say that the expected value is the median of all the possible values, sir?
No, not median. Not always median.
Sir, like x's can be 10, 30, 50, 70, or 90. The median is 50.
Yes, yes. It is also 50. Median is also 50. But suppose if I change this number from 90 to 900, then it will not be median. Then expected value will be changed.
So
Then
like
it will,
if we say like if the values of x are in an arithmetic progression, then the expected value will be the mean.
yes, not only values, but also probabilities must be symmetric. That's what I said. Values of p, if they are also symmetric, then only this will happen. Both conditions must be satisfied. Okay. So this is just example. Now here is the problem you can solve.
Sir, I had a doubt in the last slide.
Oh, last slide here.
Yeah, so what is the
Yes.
Yeah, so what is the difference between E of X and that X with a line above?
Oh, this is bar x, that is mean. Mean is just adding all the numbers and dividing by number of observations.
Yeah, it's the
And the
same
expected
thing.
value includes the probability part also.
Yeah, but it's the same thing, right?
Not exactly same. Not exactly same. The results can be different also based
Oh.
on the table that we will see in this question.
Okay.
So there is chase match going on between Ram and Sham. There is 40% chance that Ram wins. 40% that Ram wins with Sham.
Sir, I just have a doubt.
Yes.
It's given that, but if A lost, then you'll get nothing. Who is A? Here.
If A lost, you will get nothing. But if A wins, you will get 240.
Yes, sir. Is A Ram or Sham?
Oh, sorry, this I forgot to change. A is Ram.
Okay.
So this was because of copy paste of questions.
And sir, is the expected value the same as E of X?
Just E of X is just representation of expected value. Just like we say, this is mean.
Okay.
So
Mean is
in
also
same way, this is
expected value, right?
Sometimes when probabilities are not given, then we can say mean is expected value. Or all the probabilities of all outcomes are same, like dice or coin. In that case, we can say expected value and mean will be same.
Same, yeah. Or if there's arithmetic progression between the probability.
Yes. There are many special cases like that. So the question here is, will you enter this bet? The probability of winning Ram is 40%. So obviously probability of winning Sham is 60%, right? Because total probability is 100%. When Ram wins, let's say now Ram is variable. If he wins, you will get 100 rupees. Oh, sorry, 240 rupees. Okay, and if he loses, if he lost the match, then you will get 0.
Sir, I sent my answer to you in the chat.
Yes. So this you will consider as X because these are the values. And probabilities are like this. 40% for Ram, and that is winning Ram, and 60% for losing Ram. So just tell me, can we multiply this to get expected values? Can we multiply
sir.
these,
No, sir.
or these are incorrect values?
Sir, I think these are incorrect values.
Why?
Because we are like, when we enter the bet, we are giving 100 rupees.
Right. So
That's
there
why
is
we subtract 100.
payment of 100 in both cases. Right, so values of X will not be 240 and 0. It will be 240 minus 100, that is 140, and 0 minus 100, that is negative 100. Now we can multiply this. We can get XP, that is X times probability. So 40 and 4 are 56. Then negative 100 times 0.6 will be negative 60. So when we add this is giving us just 4, negative 4. Which means when you enter the bet again and again continuously, you are expected to lose 4 rupees. Okay. Here in the
You are
question only you
expected to
cannot
lose
tell.
4 rupees every match, right?
Yes, 4 rupees. No, not every match. In total, you will lose 4 rupees in total. Suppose if you are playing infinitely many matches, then for that infinitely many matches, your loss is 4 rupees. Okay. In the second case, instead of 240, he is receiving 260. Okay. So the values of X will be like this. it will be 260 minus 100, that is 160. And again 0 minus 100 is negative 100. It will be same, probabilities will be same. Just xp we have to calculate again. 160 into 0.4, what it will be?
64.
64.
So we can't hear you.
Yes, yes, yes. Just connecting the device again. Okay, so 16 into 4 is 64. So here is 64. And
Sorry,
here
Omkar,
is
sorry to
negative.
interrupt you, but your voice is breaking actually, and it's quite low also.
Okay, is it clear now?
Yeah, it is better now. Yeah.
Okay, okay. So here expected value will be what? 64 plus negative 60, and it will be positive 4. So even when expected value here is greater than 0, we will accept that way because we are getting benefit. Okay, here we are not considering the time part, that how much time it will take or other such variables we are not considering. Just we are considering the value and its probability. Okay, so we will accept the second and not the first, because here we are making the 4 rupees as profit. And just if you are saying 4 rupees profit for that this much thing, why to do? Then just want to tell that bets doesn't happen in hundreds, it happens in crores. So just attach 4 to 5 zeros, or let's say 6 zeros, that you can get the actual amount.
So, but this will be for per match, right?
No, not per match. It will be the total.
But why so?
Because this is what we expecting, not from each match. What happens in total, that we are expecting.
Okay, total, all matches.
Yes, yes, yes.
Sir, is it sure that we'll get 4 rupees profit if we play in?
See, this is probability. It is not sure. Here, if I tell you using the probability and very complex probability, let's say, if I tell you that you will get profit of 1 crore rupees, again, it is not sure whether you will get 1 crore rupees or you will have to pay 1 crore rupees. So it is just probability that you can get this.
Sir?
What will happen? It is the future part.
Sir, I have one small doubt, sir.
Yes.
Sir, but we don't know how many matches you are playing, sir. So, for example,
Just we assume that we are assuming that we are playing infinitely many matches. Every time when we are calculating expected value, that expected value is just telling us not for one match, but if you play infinitely many times, then what you get? Oh, sorry. It is true that someone said that it is for one match. It is true. It is for one match you will get this, but not
yes, sir,
every match you will get 4.
Yeah, that's what, sir, I was telling.
Yes, 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 yes.
yeah, I had a doubt in that only, sir. Thank you.
No, so every match you will not get 4. Averagely for every match you will get 4.
Yeah, averagely.
That sometimes if you get 100, then it is possible that for next 19 matches you will get 0. That the average of 20 matches will be 4. It is possible, but again it is not sure, because what happens in a real life, it is different. So here is the next problem.
Sir?
Yes, yes.
Sir, so going by the expected value and assuming that we receive a profit of 4 every match, and if we choose to bet infinitely, then we'll have infinite profit.
Right, we can have infinite profit, but also we can have infinite loss, because if it doesn't work with the expected value and it is going worst to worst condition part, then we can get losses also.
Okay, sir. But assuming that the expected value holds for all the matches, we should receive an infinite profit.
Yes.
Okay, sir.
Assuming if everything went with expected value and infinitely many matches are there, then we can get infinitely much profit.
Okay, sir. Thank you.
Okay, so here is the another bet. Will you bet this or not? Means if he is given, there are 4 possible outcomes. Either he will win or draw or lose or that is lost or match will cancel. So I'm not just giving much time for this because everyone knows now how to do this. That to get first expected values. So for win, what will be the value of x here? It will be 500 minus 300 because 500 we are receiving, but we are paying 300 also. So it will be 200. Then if it is draw, then it will be 100 minus 300. Then
So the fee is 300 per match.
Yes, 300 per match. If you have played some games here, in some malls there are games like if you swipe card in that game, you are some ticket. There, if you swipe the card, then okay, wait, again network issue. Okay, so if you swipe their card in that game, then it is possible. Oh, not possible. Obviously, some cards will get or some tickets will get reduced, and you will be eligible to play one game. So it is like that. Every time you have to pay 300 rupees. Then the third possibility is of if he lost, then 100 he have to pay. So already he is paying 300, now again paying 100. So it is negative 400 for him. And if match cancels, it is negative 300. And probabilities are given. So it is 75%, 5%, 18%, and 2%. So if we multiply this, sorry for handwriting, pen is not working properly. So 200 into 0.75, what it will be? It will be 15. Then 200 into 0.05, it will be 10.
150.
It will be 150.
Oh, right.
150.
150, right, correct. Then here it will be negative 10. Then it will be negative 72.
72.
Then here it will be negative 6. Oh, is it 72?
Yeah, sir, it's 70.
Yes, 72, correct. So if we add all this, what will happen? What will be its expected value?
150 minus 88.
Yes, 150 minus 88. What it will be? It will be.
So
So it will be 62.
62.
Oh, 62. Oh, right, there is 6. Oh. And 0. 62.
So profit of 62 per match probability.
Yes. Yes, profit of 62 per match averagely. Not every match, but averagely per match we can get 62. So
It's probability, sir. It couldn't be. It can't also happen. It can also happen, right? It's not
yes,
sure.
yes. It is possible that you will get 200 as profit. It is possible that you will lose 200. It is possible that you will lose 400 or 300. But finally, if you take the average will be somewhere around 62. You have earned per match 62 averagely. Okay, now the question is somewhere similar. Just instead of 300 rupees as entry fee, what should be minimum entry fee so that you can expect winning by bet? So suppose if the entry fee is 100, will you enter the bet? If the entry fee is 500, then will you enter the bet? If entry fee is 1000, then will you enter the bet? So what is the minimum entry fee you can expect that, okay, if that is the entry fee, then I will enter the bet.
Sir, can it be 1 rupees also?
Yes, entry fee can be 1 rupee also. And obviously, if it is 1 rupee, I will always enter it.
Or can
Because
it be
its
zero?
expected value will come.
The winning as
more.
in earning money, right?
Yes, yes, yes.
Or can it be 0 rupees? Can it be free of charge?
Sir,
Yes, it can be negative also. Entry fee can be negative also.
You
That
can
is,
get
they
100.
will pay for playing us. Playing
sir,
with us.
like, if we consider the entry fee to be on way, we can solve like that. So,
Yes, so what we can do, we can just get the all possible
Sir,
outcomes.
I think it's negative 200, sir, because yeah, I think if it's
Oh,
negative, I
entry
think it's
fee. Entry fee negative 200.
negative 100, sir. Sorry.
Negative 100. Okay, possible. Let's see. So we don't know right now what the entry fee is. So let's consider that as A. So the first will be 500 minus A. Then the second will be 100 minus A. And the third will be negative 100 minus A. And the fourth will be just minus A. Okay, and its probabilities are given. It is 0.75, then 0.05, then 0.18, and 0.02. So I'm not solving this. Just take this for homework. Just multiply them. So you will get some XP. Okay, add that all XPs. Suppose here is expression for that XPs. There will be some number part, then minus some A part will be there. We want profit, right? We want profit. So just make it more than 0. Right? Expected value, if it is more than 0, that we will consider. Make it more than 0, then you will get the value of A by simplifying that expression. It is inequality. So while solving this, you should know the rules of inequalities also. Okay, how to play with it. I'm just skipping it because I want to show something else.
So,
Yes, yes, yes.
sir, should the fee, the entry fee, should it be an integer or can it even be a decimal?
It can be decimal also. It can be anything.
Sir, but then sir, so it should be round up to some number of decimals, right, sir?
Yes, yes, that you can do.
Okay, sir, thank you.
Okay. So here, one real life example we are going to see that is used in financial markets. Okay, financial analysis and such parts. So there is a manager of company who wants to buy company, who wants to buy another company. Okay, you have seen that there are some companies like Tata or Adani group, or there are many such groups who are frequently buying other companies like Reliance. If you have seen, they're continuously buying another companies. Suppose I started some small business. If my business grows very fast, they will come to me. They will pay me something, and they will purchase my business.
Like Tata again bought Air India, probably.
Right. Just like that. It happens very frequently in market. So just like here is one company whose manager wants to buy another company. Okay. So there are two companies he is looking at, company A and company B. Company B. Two companies are there. It is possible that company A will make profit of 5 lakh rupees. And there is 40% chance of that. Okay. And 60% chance is that it will make loss of 1 lakh rupees. Whereas in company B, there is 80% chance that it will earn 2 lakh rupees, and there is 20% chance that it will lose 50,000 rupees. Okay, so he have to decide that whether he want to buy company A or company B. What he want to buy, he have to decide based on this information. So how can he decide?
So whoever earns more money, buy that company.
So
Sir, the expected value for both the companies and comparing which is the greater, then the
Yes,
manager
sir.
will convince a better company.
Yes, sir.
correct. From both companies, what we expect that we will calculate. So here is the value, here is probability. So we will multiply these two, add them. It will give you expected value of that. Same for B also. We write this in proper way actually. Not expected value as E of X in both place. For company A, we will write E of XA and here E of XB so that it will be easy to understand. So once we get both expected values, we compare which is more, that we will purchase. That manager we will purchase because we are not in that position. Okay, one more example I want to take. Actually, it is a large example.
Sir, you should go for company B.
Company B is profitable. Okay, if
Yes, sir.
its expected value is more, then
Yes,
he
sir.
will
It is
go for more.
10,000. 10,000.
Yes, yes.
Yes, sir.
So just by looking towards these numbers, that company A can make 5 lakh profit and B can make only 2 lakh profit, we cannot decide based on this only, right? Expected value is important. Now here we are just considering two parts only, that is probability and what the result can be. We are not considering that who is the manager, what is his efficiency, who are the workers, what are their efficiencies, then in how much period they are earning this and how much period they are earning this. There are many variables. There is much more work that can be done in real market. Not only based on expected value, we take the result, but for this level, it is okay. Now the question, or just I am here writing while explaining. So here is the person and here is his home. Okay, here is home, home sweet home, and here is his office. Here is road in between. So he left the home and he wants to reach the office. Suppose this distance is 100 kilometer and he is driving at let's say 40 kilometer per hour speed. Then we can directly tell by just dividing these two that he will reach the office in 2.5 hours, right? But there are not only these variables which decides our time. There is one more variable, traffic. There is another variable, traffic signals, right? So let's consider these two now, and here I'm giving one chart that whenever he is leaving the home, there are three signals in his path. There are three signals. Okay. Probability of getting a red signal is 40% of for each signal. Probability of getting red signal is 40%. Whenever he gets red signals, he have to wait. He have to wait. Let's say 30 seconds. 30 seconds he have to wait every time. And of course, when he get green signal, he will just pass through the signal and not stop. So minimum time he will require is 2.5 hours. That is 2 hours 30 minutes. But if he gets all three red signals, then that 1.5 minute is increasing. So plus 1 minute 30 seconds will be increased. So the time will be minimum 2 hours 30 minutes or 2 hours 31 minutes and 30 seconds.
So, but the traffic we have not calculated.
Yes. Traffic we have not yet seen. We are just saying for signals. Okay. So I'm giving here now two charts. First is now signals also are not like this. Always we will get only that many seconds. Okay. Here is signal part. Either we can get the signal for 0 seconds. Here is a seconds I should write. 0 seconds signal or 30 seconds signal or 60 seconds signal or 90 seconds signal or 120 seconds signal. Probability of getting a 0 second signal is 60%. 60% of time he don't get the signal. And 10% probability for all the other possibilities. Okay. There is one more thing, the traffic part. Traffic. Sometimes there is no traffic. So probability of that is 50%. Okay. And when there is no traffic, he takes 20 minutes. Okay. When there is light traffic, then he takes 25 minutes.
So 25 minutes for?
When there is light traffic.
For what? For region?
Yes.
But over there, so this is another question.
Yes. This is another question. It takes 25 minutes for light traffic. Okay. And the probability of that is 20%. 30 minutes for medium traffic. 30 minutes, and probability of that is.
So, but
20%.
your traffic ka time doesn't include the signals, right?
Yes, it doesn't include signals. Signal part is different, traffic part is different. Okay, and there is also heavy traffic.
So,
if there
for
is heavy
we
traffic,
calculate the traffic delay, we should stack the signal time on top of the traffic time.
See, in traffic part, we are not considering signal part. They are completely different.
Okay.
So, okay. So for heavy, probability is 10%. So these are different two variables. Signal is variable, traffic is variable. Now here is one note that there are three signals in the path. Okay, this is the only node. There are three signals, and you have to find expected time to reach. How much we should expect the time?
So like in traffic where you have written 20 minutes, so does it get delayed by 20 minutes or like?
No. Total time is 20 minutes. Okay, because of traffic. In that, we have not considered the signal part. Just write down this. I'm not sure whether.
Okay, just wanted to inform we have less time left. Yeah.
Yes.
So,
yes.
So when you say there are three signals, then how can you say 120 seconds or wait for 120 seconds, sir?
So this 120 seconds or 90 seconds or is the number of seconds are for each signal.
Oh, got it, sir.
So can I say the answer? Can I personal chat it to you?
Yes.
We need to write the time taken for reaching from one place to the other, right?
Yes. Expected time.
Yeah.
What time you expected that?
Sir, I personal chatted it to you. My answer.
Yes.
Sir, even I have sent my answer to you.
Okay. Looking towards the chat. So here the thing is simple, that we just need to multiply these values and probabilities. So here you will get the signal part. You will get 0, 3, 6, 9, and 12. And when you add this, you will get 30 seconds. But it is for one signal. So for 3 signals, we are expecting 90 seconds delay. You can expect 90 seconds delay for signals, 3 signals. And for traffic part, again, the values will be like this: 20 minutes into 50% will be 10 minutes. Then here 5, here 6, here 3.5.
Let's observe to 24.5.
Yes, 24.5. That is 24 minutes, 30 seconds. So this is the time, expected time because of traffic. Delay because of seconds. Oh, sorry, signals. So if we add this, we will get 26 minutes. So we can expect that averagely we can reach the office in 26 minutes. Okay, it is possible. Sometimes we take 90 minutes, or sometimes we take just 20 minutes or something like that. But averagely we will reach in 26 minutes. It will decide, it will help us to decide how early we should wake up to reach the office on the time.
Omkar, can I tell you that it's 5:15 already?
Oh, yes, yes.
Yeah, thank you.
Okay, so my part is also almost covered. So if anyone have any doubt in these expected values or these types of questions, then they can ask. See, these expected values, you can use while playing board games also, or like when you are buying something. Like suppose you are buying 2 t-shirts.
Monopoly.
Yes, yes. If you are buying suppose 2 t-shirts, here is one t-shirt, here is another t-shirt. So if you like this t-shirt 60% and this is 40%, and you can just figure it out their values for you, which will be more valuable for you, not in terms of money, but in terms of attachment. Then you can get your pick up one t-shirt from that. So what we discussed in the beginning, that there are 2 types of events, right? One is deterministic, which where we know the exact results, and the another is probabilistic, where we are just guessing the results. So this expected value helps us to keep balance between these two. You can search and study about that also. So expected value helps us in deterministic or probabilistic events. It is very fast part of for study also. Okay, so that's it from my side.
So,
Yes.
sir, could you give some problems to explore around for homework?
Yes, I will send some problems.
Okay, sir. Thank you.
Before today evening, I will try to send.
Okay, sir. Thank you.
Okay.
Thank you, Omkar. That was a wonderful session, and all the participants interacted really well. So thank you so much. Yeah.
Thank you, sir. It was amazing.
Thank you, sir.
Thank you, sir. It was a really nice session.
Sir, the session was wonderful.
Thank you, sir.
Thank you, sir. It was
Thank you so
amazing.
much, sir. It was really amazing.
Okay. So
Thank you,
is there
sir.
the next lecture on same link?
Thank you, sir. I enjoyed the session.